Hi guys, more of 4.4b notes. We're on page 74, I believe. Yep. And we've already done example number 1 and example number 2. We're writing function notations. We're writing what the output would be based on the rule of the input. And we're going to go through maybe 2 more examples on this video, and then I'll have some instructions for you. So if you look at the instructions for example 3, it's a kennel charging so much per day to board dogs. However, every time the dog comes, they must have a flea bath that has a cost associated with it as well. That's not a flea bath every day. That's just when they get there. So we're going to write a function rule that represents, and a function rule, remember, is the same thing as an equation. I want black. equation, equation that represents the total cost C, so they give us the variables, for D days of boarding the dog, including the bath. So the cost C is a function of how many days you board your dog. That is going to be equal to the $12 that it costs for the flea bath plus $15 for every day D that you spend there. So that would be our equation. The cost is a function of the days, and the rule is 12 plus 15D to calculate your total cost. So then we can use our equation, our rule, to answer part B. How much would a 10-day stay cost? So the cost of 10 days, we can plug in 10 for the D, is going to be equal to 12 plus 15 times 10. So that is going to be, what, $162? 150 plus the 12. And then it says, would a 5-day stay cost half as much? Probably you could just see this answer. You know the answer to this without having to calculate it, but let's calculate it anyway. C of 5, C for 5 days is equal to 12 plus 15 times 5, which is going to be, what's that, $87. So no, that's not half of 162, and the reason, the explanation, is the flea bath. Because of the flea bath, you can't cut the cost of the flea bath in half. It's still, just because you stay fewer days, it's still $12. All right, let's look at the top of the next page. This has got a geometry component to it. It says, move this out of the way so I can see exactly what it does say. So it says a rectangle has a length that's 3 times the width. So anytime I even see the word rectangle, I start drawing. I rarely ever will work a geometry problem without drawing a figure. 3 times a length that's 3 times the width. So if the width, well, let's keep reading for a minute. Write a function rule that represents the area A of the rectangle with a width of W. Okay, so if the width is W, then we're going to write the length, instead of L, we're going to write it 3 times as big as W. Of course, we're going to use the formula for area is equal to length times width, but instead of writing it like this, we're going to say area as a function of width is going to be written, instead of with the variable L, we're going to replace it with an equivalent, which is 3W, 3 widths, because they are asking us to write a function rule that represents the area as a function of the width. So that would be 3W times the width, and we end up with the area as a function of width, 3W to the second power, 3W squared. And then it says use that rule and tell me what is the area of the rectangle if I give you a value for the width. So the area when the width is 5, so A of 5 is how we would say that. A of 5 is equal to 3, plug in the 5, and you end up with 3 times 25 or 75 square centimeters. Okay, so that's a couple more examples, and I want you guys to work example 5 and example 6 at home. I don't think I'm going to put them on the video check because it's going to be too hard to enter the answers, but if you will work them at home and then be prepared to, maybe we'll do them on the board at class, that would be great. The video check for 4A and 4B is going to consist of only problems from the 4B practice, and I will put those on the video check. Thanks for watching.